Okay, so I'm putting a different motor on a tractor. Now this particular tractor is a Massey Harris Pony. The original motor spins at 1800 RPMs, revolutions per minute. I'm putting a twin cylinder Briggs on there, which spins at 3600 RPMs. Now the thing is, granted the Briggs twin cylinder is 18 horse. The old engine, which is a Continental, is 11 horse. But you got to remember there's torque. Torque and horsepower are two different things. So what I have to be able to do, since the Briggs engine has less torque, I want to slow down the RPMs by the time it gets to the drive line. So the motor may be 3600 RPMs, but at the end, where it goes to the clutch, it's got to end at 1800 RPMs. So what I did, I took random, like round objects, you know, cans of cat food, you know, jar cans, bottles, all these things, different sizes, and I made all different circles, cut them all out. Each circle, I have an indication line. Alright? And what I did, I wanted to figure out, okay, I have to step it down. Now you obviously, or not necessarily obvious, depending who you are, but you don't want to just reduce the shaft once. Like take it, let's say, from a sprocket this big, or actually, okay. One thing to remember, an engine and a transmission. If you have the big sprocket or pulley on the motor and the small one on the drive, you're going to increase the speed. You want to have the smaller one on the motor and the larger one on the drive. Okay. Now, so what I did, I have to decrease it twice. So basically I can't go from just this to this because it's not geared down low enough and it'll cause drag and it won't be able to do it. You have to step it down twice, so you have to have a jack shaft, which would mean you have your motor, then you have another set, and then that set leads to the final. So what I did, after coming up with my different sizes here, find the ones that work the best. Okay. Let's see here. Now, let's say this is the transmission or whatever. Now, we have the line, alright? So we want to step it down the first time. So I use basically just cardboard. This is a cereal box, which allows me to put a little pressure to keep these cardboard wheels aligned. Alright, now obviously this is not very scientific, but you know, you do what you can do with what you got. Alright, hold on. Yeah, don't get upset if that happens a couple times. Like I said, you got to keep trying. But when you don't have the programs on the computer, you do what you can with what you got. Alright, so I end up here, and we end up here. Roughly 3/4 of the way around. Alright? Now remember, we want to decrease it by half. So, let's take this one and find which one fits here. Like I said, I've already done this like 100 freaking times, so, and that ends up 3/4 of the way around this. So when we set this up, 3/4 of the way around the big one, and the small one is 3/4 of the way around inside of that one. You can see we have decreased our ratio by half, and that is how I determine roughly how I'm going to gear down my system. Now I just got to basically take these measurements, which each measurement, this one is 4 6/16, this is a 3 6/16, this is a 2 6/16. and I just have to transfer that over to sprockets and, you know, my jack shafts and everything else. And that will basically step down from motor, jack shaft. So the motor is going to have one, jack shaft will have two of these, because you'll have one going, then you'll have another one going down to the transmission. That is stepping it down 2 times to give you 3,600 to 1,800 RPMs.